Okay, let's sketch the graph of this derivative. I have split this function into 5 sections. The first section right here, the original function is part of a parabola. The second part of our function is a line. The third part is a line. The fourth part is a horizontal line. And this part here is actually a fourth degree, which is a fourth degree function is kind of like a fat parabola. So we're just going to tell you that ahead of time. This is a fourth degree. All right, so moving left to right, this section from -10 to -5 is a parabola. That's degree 2. So our derivative graph will be degree 1. It will be a line right here. So we need 2 points to put in a line. So we're going to put our first point. We're going to get our first point from this minimum. At that minimum, the x value of -7, the slope of the tangent line is 0. So there will be a x-intercept at -7. Okay, again, at -7, the slope of the tangent line is 0. So the point 0, or the point -7, 0, is on the graph of the derivative. Now to get a second point, we just pick any other x value in here. Okay, I'm just going to go over here to -9. Okay, so I'm going to put in a tangent line right there. So I'm going to put in my point down here at -9. What is the slope of my tangent line? So I'm going to go over to -9 on the x-axis. I'm going to go up to the graph, and I'm going to put in a tangent line right there. All right, I don't have a straight edge, so I'm just going to kind of wing it. Okay, now I'm going to put in a slope triangle. Now again, this is a super duper rough estimate, but it's approximately a slope of -1. Okay, so down here at my point, at -9, the slope of the tangent line is -1. So I'm going to plot that point. -9, -1, right here. All right, and I'm going to put in my line, and that line is only going to go up to -5. Okay, so again, this is a parabola right to here. The graph of the derivative of a parabola is a line. We are decreasing right here all the way, and we are below the x-axis here. And then from this minimum right here, we're increasing, so the graph of our derivative is above the x-axis. All right, so there's section number 1. Let's move on to section number 2, between -5 and 1 on the x-axis. This is a line. The graph of the derivative of a line is a horizontal line through the slope of this line. So let's put in a slope triangle. I'm just going to pick 2 easy parts. It looks like a slope of +1. Okay, so our slope here is +1. So then we're going to put in a horizontal line through 1 right here. And that goes all the way here. Now, check this out. There's a hole here at the x value of -2. So on the graph of the derivative right here, I can't have any y values. So that is going to have to be a hole right there. All right, so we're going to put in a hole right there. All right, so between -5 and 1, the graph of our function is a line, so the graph of that derivative is a horizontal line through the slope. Okay, let's go to section number 3. Now, before we move on, let's talk about this cusp. I can't take the derivative at a cusp. So all along this vertical line where the x value is 1, I can't have any y values on the graph of my derivative. So I have to end this piece right here with a hole. There has to be a hole right here. Okay, now let's find the slope of this line. It is negative. Let's put in a slope triangle. It looks like I have a horizontal change of 1 and a vertical change of 2. So that slope is -2. So the graph of the derivative of this line will be a horizontal line through -2. Oops, down here, right here. So I need to have an open circle here because there's a cusp. And check it out here. Here's another cusp. So I have to have holes on both ends. So I'm going to put in a hole here. I'm going to put in a hole here. And there is the horizontal line through -2. So the graph of this line is a horizontal line through its slope of -2. Again, this is decreasing. Our derivative is below the x-axis. All right, so there's section number 3. Let's move to section number 4. This little piece right here is a horizontal line. We know that the slope of a horizontal line is 0. So the derivative of a horizontal line is a horizontal line through 0. There is a cusp here and there's a cusp here. So I need to put in an open circle right here and an open circle right here and a horizontal line through 0. Okay, so again, the graph of the derivative of a horizontal line is a horizontal line through 0, its slope. Cusp here, so this has to be open circle because I can't take the derivative at a cusp, can't have a y value here, and then there's a cusp here. So I need an open circle here. All right, finally, section number 5. This right here is a 4th degree. All right, so the derivative, so this is a 4th degree. So we are going to take the derivative and it is going to move down to a 3rd degree, which is a cubic curve. All right, so let's just have a little crash course on cubic curves. It either can go up from left to right, point of inflection, or it can go down from left to right. So we got to figure out which one we have. All right, right off the bat, there is a maximum right here. Okay, so there has to be an x-intercept right there. So it's going to cross right here. All right, now this is increasing. So right in here, the graph of the derivative has to be above the x-axis. Right here, we start decreasing. So the graph of the derivative from this x value on has to be down here. That's how we know that the cubic curve is going to be coming down from left to right, and it's going to hit our point of inflection, the x-intercept, and then it's going to go down right there. Okay, so there is our derivative graph. Let's review. Moving from left to right. Parabola to a line to a horizontal line. There's a hole here, so there has to be a hole on the derivative because I can't put a tangent line there. There's a hole here because there's a cusp here, so I can't have any y values here. I have a decreasing line here, a slope of -2, so the derivative is right down here with a hole on each end because of this cusp and this cusp. This section is a horizontal line, so the derivative is the graph of a horizontal line through 0, and then the graph of a 4th degree is a 3rd degree cubic curve. We are increasing, so we are above the x-axis till the x-intercept, and then from that max where the x-intercept is, we are decreasing, so our cubic curve, our derivative graph, is below the x-axis. Okay, hope that helps.